Okay, let's look at some JSON. I'm going to show you a small web app that I wrote just to demonstrate how JSON is working in web apps. The goal of this app is to organize cat photos into a binary search tree so you can look them up later by name and delete parts of the tree that you don't care about anymore. So most of the app is a server. It's running on the same computer that the web browser is running on, but it doesn't have to be, and normally it wouldn't be, but that just makes the setup for this video a little bit easier. So let's use the app. Here I've just looked up some pictures of cats that I like, and the way it works is we pick a name for our picture, we paste the URL, click insert, and because our tree was empty, this cat picture went into the root of that tree, and we have two subtrees that are both empty. So let's fill them with some other cat pictures. Here's a nice large cat. Okay. The name large is greater than the name box, so it went to the right subtree. We can zoom in and see. Yeah, slightly larger cat. And let's paste this guy in. Okay, and let's get one more picture for good measure. And I'm going to give him a different name that's smaller than box, just so he'll show up on the left. How about that? Okay. Yeah, so there we go. We have our cats in this binary tree. And just to prove that this isn't all running in the browser in JavaScript or something, that there actually is a server, I'll pull up another web browser and we'll go to the same URL, localhost, index, and there's our same data. And we can exercise this app in some other ways. So we can delete part of the tree. Let's delete the large cat and all of his ancestors. Okay, that's done. And if we refresh in our original browser, we see, yeah, in fact, there's a single data set, and both of these browsers are operating over the same data. All right. So how does this work? What is the normal way that that web apps are organized, and what's happening in the URL in order to communicate the information about what the user wants to do back to the server to put cats into the tree or whatever? You might think that we'd have to look at the code to find out the answer to that, but in fact we don't. We can get a lot of clues about how this works just by using the developer tools that are built into pretty much every web browser. So I'm right-clicking here, inspect element, and click on network. And let's see what happens when we load this page up. Okay, we see this thing tree over here. This is a listing of all of the requests that the web page made after we started loading it. A request means basically a block of ASCII text that the browser sends to the server when the browser wants to do something, or when the user wants to do something. Now let's take a look at this one, tree. Okay. This is kind of interesting. So what we see under general is that there's this URL that looks a bit like our URL, localhost/index. It's localhost, but it has this API/tree thing in there. And what that means is that there's some part of this page that was pasting URL up here on your behalf, and the browser was kind of secretly going to that URL behind your back and fetching some data. That's actually how almost all web pages that do kind of non-trivial things work now. So for example, if we go to YouTube and we load up a video, right? Just refreshing this one. Oh, sorry. Yeah, we can see, not just one little entry in this table called tree, but something like 20 different requests went out. So 20 different URLs got hit just by us visiting this single URL here. Okay. And then what actually happened when we hit this URL? We don't have to guess. We can type that in. It's just a regular URL. That's what we got back. So on our behalf, the browser went to this URL and the server returned this data to it without anything happening on the screen. Yeah. And then the page's job is just to process that data. So normally, whatever JavaScript you've written in HTML and CSS, that should be kind of a thin wrapper that just does a little bit of work to draw some data on the screen. But there shouldn't be anything in the HTML or CSS or JavaScript that does anything algorithmic. Like when we insert a cat into this tree, we're not doing the tree search and the tree insertion in JavaScript. We're not doing it in the browser. We're letting the server do that work. So the browser's job is just to interpret the user's actions here and then to send them along to the server. And then the server's going to send us back some other information. So let's see what happens when we insert a picture. So let me get URL. Okay. We've got a few more things over here. Well, I happen to know that this entry is just the previous one that we looked at, so the browser isn't clearing this list between things that we do on the page. But this one is new, so we see that the browser on our behalf went to this URL, localhost/API/insert. And we can take a look at the actual information that it sent to the server when it did that. Okay, went to this URL. Here's some kind of extra data. Let's not worry too much about that now, so never mind. And yeah, it's kind of hard to make much sense out of this kind of stuff. And all this business about the browser going behind our back to certain URLs and sending data and getting data can be a little bit opaque because, well, the browser doesn't want you to see that. That's kind of hidden transactional stuff that's going on to make the rest of the website look nice. But for web developers, we kind of do want to see what's going on because that's how we're managing our interaction with the server. So there's a very nice tool. It's called Postman. You can get it through the Chrome App Store, but it's free. At least the kind of regular features are free. And this guy works a lot like a browser, except that it's not going to render the HTML for you. It's just going to tell you with a lot more detail what data is going to the server and what data came back. But the URL side is the same. So if we go to localhost/index.html, that's the root of our page. Okay, this is what comes back when you go to that URL, HTML. And when the browser gets this HTML, it renders it into a page that you can look at, renders it into this. Now, the next question is, when the user does some stuff on the page, what's happening behind the scenes? Well, that URL that we found before, we can type that in here to get some more information about what was happening. Remember, when we went to index.html, we got this tree request, and we saw that that went to this mysterious localhost/API/tree URL. So let's visit that, and we see what came back from the server. But it's that same block of stuff that we saw before, but it's formatted a little bit more nicely here. Postman formats JSON for you in a nice laid out way that you can see what's going on. And this is just the JSON representation of our tree. And it's a little bit messy because our tree's got a lot of stuff in it. But if we kind of clear it out, let's delete the root node box. Delete. What happens when we go back to this API/tree? Okay, now it's returning null. So that's another JSON value that just means empty. And if we insert a single cat, you don't have to use real URL here. Okay, so that's a broken link because there's no such picture test.jpg, but it's not important. We'll go back to API/tree. And here we see the JSON representation of the current tree, which is much simpler. The left subtree is null, the right subtree is null, and the payload for this node, here's our data that we put in. All right, so that's JSON on the output side. The server is outputting JSON, and the browser is getting the JSON back. But also often JSON is used in the other direction. So what happens when we're clicking this insert button? That's also using JSON to communicate to the server, but we're sending data to the server in that case. And let's see if we can get some information about what that data looks like as we're sending it. We'll look at one of those requests. Again, no, it's kind of hard to extract much information out of here. But we can see the URL that we hit. It was this one. This is the URL that the page went to when we clicked insert. So what happens? Oh, and also we'll just notice that this request method is post. I won't talk too much about request methods, but just notice that for now this is saying post. If we go to that URL, insert, and then we set the post request method, see what happens. Alright, we got some sort of error message out of the server. And that's because the server was expecting to get some data. Requests in HTML can have data associated with them. That fits in a part of the request called the body. And if we send along some data with our request to that insert endpoint, well, we can send that data to the server. So let's first just try sending kind of any arbitrary JSON value that we think of. How about null? What happens if we send null? We get some kind of cryptic error message from the server. But if we send a JSON object, this looks better. We got something back from the server. And what did we get back? Well, we didn't get back like an OK code or an error code. It's just for convenience, the server happens to send back the entire new tree after the update that you asked for. So this tree is going to have the data that we just put in. An element whose name is A and whose URL is test.jpg. But that name matches one that I used before, so let's actually make sure that some new data is going in there. Yeah. Okay, so now we have an element whose name is AB and whose URL is test.jpg. And if everything I'm saying is true about there actually being a server, a single server behind the scenes with a single tree in its memory, then we should see that when we ask for the tree back at the page. And indeed, yeah, here's the tree, A, B. I should go back to using real URLs. Alright, we also have this delete button. What happens when we click that? Okay, we see that there's this other URL that looks like this. localhost/API/delete $ID equals. So in this case, let's actually try that with a real name. Oops, excuse me. Yes, here's our most recent request. Here's the URL that got sent. And we can try going to that URL in Postman. Question. And that request had a method of get. So we'll send a get request. Okay. Status 200. Okay, no problem. In this case, we didn't have to send along any JSON. The only data that we needed to send the server was the ID of the cat picture that we wanted to delete. And since that was just a single name, that fits in the URL just fine. So the URL is a perfectly good place to stash some data to send to the server, especially if there's just one or two parameters. We could have done this for insertion too, but I wanted to show JSON going to a server as well as coming back. So that's why there's no URL that looks like this. Although that would have worked. Okay, so right, what I wanted to show you was a single-page web app that does something that's server-backed, which is communicating with the server over JSON mostly, but through URLs when JSON isn't necessary because the data is very small. And that's it. Any code for the server and for the page I'll post under the video if you want to have a look. It's up on GitHub and it's pretty opaque. But that might be a next thing for me to go over because there's a nice division here between the business logic, like the real work that the server's doing, inserting items into a tree and deleting them from the tree, on the one hand. And on the other hand, we can see exactly how those data types get turned into JSON and how you can turn JSON into data types, which is a big part of the job of a web app because so much of a web app is just about communicating serialization.